We're continuing on in the video series going over the Chapter 3 group review. This video goes over all the problems on there that deal with trigonometry. And so we're going to focus on how do we know what we're trying to find based off of the way the prompt's written, based off the way that the graph is given, or based off what it's asking us to find, what information, what processes. We need to know, though we see trigonometry, the way it's written kind of tells us the approach we're going to use. So this video covers problems 5, 9, and 10. Now in problem 5, look what it's asking us to do. We're asked to solve the following trigonometric function equation from 0 to 2 pi when you have 4 cosine of x plus 2 radical 3 equals 0. So a lot of information. So let's go like left to right. Well, we're going to solve the equation, which means we're trying to find x. And if I'm looking at x represents an angle. And I want to find that angle from 0 to 2 pi, which means I'm probably dealing with the unit circle here. And so I'm going to sketch my unit circle off to the side, and I'm going to focus on that. And my job is to find the angle, or angles, plural, that fit the ratio I'm going to find in my equation. So I'm told 4 cosine of x plus 2 radical 3 equals 0. So my job is to find x. So I'm going to isolate my cosine of x first. So I'm going to subtract the 2 radical 3. So that's going to be a negative 2 radical 3. And I'm going to divide by 4. Now when I divide by 4, again, think of it like coefficients. The negative 2 over 4 becomes a negative 1/2. And that radical 3 is just going to stay. That's it. Now that's not my answer, but that's my trig ratio that I can use in my unit circle. The cosine of x equals negative radical 3 over 2. So when I'm going through and I'm looking at this, I'm going to figure out, well, what is, if I'm looking at the unit circle, cosine? Well, do remember, in the unit circle, your x value represents the cosine, and your y value represents the sine. And so when I have cosine of x equals negative radical 3 over 2, I know I have a negative x value, which means I'm focusing over on that left-hand side of the unit circle where my x's are negative. And that negative value is negative square root of 3 over 2. Which that, by the way, is closer to negative 1 on it. So when I'm drawing it, I'm going to go, okay, negative square root of 3 over 2, it's probably going to be about right here. I can look at the decimal in the calculator below if I wanted to, but I'm just going to know it's going to be further than negative 1/2, closer to negative 1, and that's the x value. And what I want to do is I want to find where on that circle you have that x value. So I go up from there and I go down from there. Which means the two angles I am trying to find are right here. It's this one that's in the second quadrant, and it's this one that's in the third quadrant. And I should know that because in the second and third quadrant, my x values are negative. Well, what are those angles? Well, if I look at it and I think about it, in this case, it is closer to the x-axis. So when I'm trying to figure out what angle in radians, I'm trying to think of, okay, am I dealing with pi halves, pi thirds, pi fourths, pi sixths? And I need to go and look at it. Well, pi sixths is closer to the x-axis. So I know it's going to be something over pi sixths. Well, in this case, I'm slightly less than a full pi, because remember, it's 0 to 2 pi. So if I go around, hey, that one's slightly less than 1. So this, most likely, if I solve for x, is going to be 5 pi 6, slightly less than 1. Now, this one down here, that's slightly more than 1. And so that's going to be 7 pi 6. Now, this video doesn't talk about it. No, sorry, this problem doesn't talk about it, but I'll talk about it in the video is, what if we're closer to the y-axis? So what if we're slightly closer to the y? Well, in that case, it's something over pi over 3 on it. And remember, if it splits the quadrants, that is pi fourths, something pi over 4. And so closer to the x, pi 6, closer to the y, pi thirds, quadrant perfectly split in half, pi fourths. Number 9. Again, look at the difference. This is why I like doing this video with 5 and 9 together, is because you may be confused because it may look similar. But this one just says, hey, sketch a triangle that's represented by the trig ratio. So remember, if I'm telling you in this problem that the sine of x is negative 24 over 25, I'm telling you a ratio of the sides. My opposite side over my hypotenuse. it's not the same as what we just did over to the side. It's not the same as finding the angle. Here it's saying sketch a triangle that's represented by this ratio. So in other words, sketch a triangle that has these sides, this opposite side and this hypotenuse. That's what that first part of the sentence is telling you. Then use that triangle to find your cosine and find your tangent. So I'm not finding anything with x. I'm finding ratio of sides. Find the cosine of x and the tangent of x. So my job is I'm trying to find the cosine of x. Well, cosine of x is adjacent over hypotenuse. It's that ratio. And tangent of x is the ratio of opposite over adjacent. So I'm trying to find the ratio. In this one, it says, hey, solve. Get x equals. This one's saying, hey, find the ratio, which means I need my triangle. So that's hence sketch the triangle represented. So I'm going to see it's in the fourth quadrant, so I'll only focus on drawing on the fourth quadrant. So go down, and I'll come across. So I'm in the fourth quadrant here, and I'm going to draw my triangle. Now, drawing the triangle, we know my opposite side is negative 24, so I'm just going to come down. It doesn't need to be perfect or to scale, so here we go. A triangle in the fourth quadrant. Here's my angle x. The opposite side, which is right here, that side is negative 24. And I just know it's 24, but I know it's negative, not because of this, but because I'm going down. And my hypotenuse is 25. And so now, you have a right triangle. You know 2 out of the 3 sides. I'm thinking Pythagorean theorem. So I know a squared plus b squared. And remember to put the negative 24 in a parentheses when you're going to use your calculator. And in this case, I will get a squared equals 49. And so a is 7. Now, by the way, you may be asking, well, Mr. Ainsworth, when you square root, you need to do a positive and a negative. And you are right. I should go, hey, it's positive or negative 7. But I'm looking at my picture down there, and I can see I'm in the positive x's. So I'm ignoring the negative 7 and just saying, hey, this is a positive 7. Well, now I have my adjacent side. So my cosine of x is 7 over 24. My tangent of x is my opposite, negative 24. Sorry. Again, I'm not going to edit it. My 7 over my hypotenuse, which is 25. Sorry about that. The adjacent side is 7. The hypotenuse is 25. Now for tangent, the opposite side is negative 24, and the adjacent side is 7. So refresh as I made a mistake there. Cosine of x is adjacent over hypotenuse, so my adjacent side is 7, the one I found. My hypotenuse was given to me as 25 in the original trig ratio. Tangent of x is opposite over adjacent, so the opposite side was negative 24 given to me, and my adjacent side of 7 is the one we found. So there's the difference between 8 and 9. We're not dealing with a unit circle for number 9 because we have, sorry, number 5 and 9, because number 9 has a hypotenuse of 25. So we're going to sketch it out. Number 5 dealt with the unit circle, and that's what this was telling us on, is we're going to focus on the unit circle for this one. Now, number 10, we're not being asked to graph. We're just being asked to analyze what is my midline, what's my amplitude, what's my phase shift, what's my period, and the whole follow a map, trademark Mr. Ainsworth. So when we're going for this, we need to remember the general structure. You know, your A value affects the vertical stretch and even affects the reflection over the y-axis. Sine of, in this case, x minus my h plus my k. I don't have any value in front of my x. I don't have a b value at all. And that means a b is 1 because you're multiplying there. And that's going to affect our period. So if I look, my midline is based off of y equals k. So in this case, y equals negative 7 is my midline. I would do a dashed horizontal line. That's going to be the midline for the trigonometric equation. My amplitude is going to be my a. Now in this case it's 4. Now be aware, even if this were a negative 4 up here, the amplitude would still be 4. The only thing that negative tells you is that it is reflected over the x-axis, or the graph is flipped from the starting point. So even if it was negative, your amplitude is always positive for it. And then you have your phase shift. Now when I'm looking at my phase shift, your phase shift is based off the H value, and it's kind of the opposite of what you see. So since this is the structure, and I see that it's a positive 3 pi over 2 there, then I'm going to realize my phase shift is negative 3 pi over 2. And then I have a period. Period is going to be 2 pi over your b. In this case, like I said, we don't have a b number there, which means the coefficient is 1. So 2 pi over 1, there is no change in period. It is 2 pi. Now, I'm not going to sketch the entire thing, but I do want to kind of refresh your memory on this. If I'm going through, my midline is going to be at negative 7. So we'll call this negative 7. My amplitude is 4, so I will go up 4, and that would put this at negative 3. I would go down 4, and that would put this at negative 11. So midline amplitude, good. Phase shift, negative 3 pi over 2, which means, let's see, sine usually starts on the middle. I would slide, so if I just grab that, this over negative 3 pi over 2, wherever that would be. And I should label my x-axis. I'm just going to put it right here for now. And then I would go a period of 2 pi, wherever that would may be. I would split in half to get my 4 quadrants. Sine graphs, where they're positive, rise first, they'll fall to midline, fall, and rise. And I would repeat that. You have a problem that deals on your closure packet with completing 2 cycles of these. So you can go back and take a look at that, but this is the end of the trigonometry review for it. Do be aware. Make sure you understand how to do each problem based off the way the prompt is given. If you see the 0 less than or equal to x less than 2 pi, you're dealing with the unit circle. Now, if I'm given a trig ratio, hey, the sine of x equals 7/10, I'm telling you the sides of a triangle. So I'm telling you, hey, sketch the triangle, use Pythagorean theorem to find the other ratios of the sides. So there is the trigonometric review, and we'll finish the last one with just the sigma notation.